Once again, we're going to take a look at a geometric view of a 3x3 system. In this case, we're looking at a system that was inconsistent and how that would look geometrically. So we're going to put in a plane for each of our three equations. So here's our plane for our first equation. We can see it there. And then we'll add in our plane for our second equation. And once again, those intersect at a line. Now, when we add in our plane for our third equation, this is actually really interesting what happens. If we look and rotate this around a little bit, what we start to see is they all intersect at lines, but they intersect at three distinct lines. You can kind of see this triangle formed here. So let's put in their lines of intersection so we can see them a little bit better. And so what happens in this case, the system is inconsistent because there's no place where all three planes share points at the same time. So while the planes aren't necessarily parallel, their intersections, they don't share any common intersections. So this is one possible geometric view of what happens when we have an inconsistent system. The other would be to have two perfectly parallel planes. And just to give an idea of what that would look like, let's take out one of our planes. So let's take out the orange plane here. And what we'll do is we'll replace it with a parallel plane. And so what we can see is the green and the red plane are actually perfectly parallel if we look at a side view of them. So they're never going to intersect. Now the blue one's going to intersect the green, and it's going to intersect the red, but at very different points. We can see where it's going to intersect the green there. The red, it's going to intersect somewhere off of where we're looking. So those are the possibilities that will give us an inconsistent system. Two of the planes are parallel, or all three of them intersect, but they don't intersect at the same place.